So we've just talked about finding the angle of intersection between two planes if they do intersect. Right? We talked about that if the two planes intersect, they do so in a line. And we also talked about what it means for two planes to be parallel. So let's see these concepts in action through an example. Right? So we're going to ask, do the planes given by 2x minus 3y plus 4z equals 5 and x plus 6y plus 4z equals 3, do they intersect? And if they intersect, we want to find those two pieces of information out. What is the angle that they intersect in? And, well, we know how to find an equation of a line, so let's find an equation for the line of intersection. Okay? So, well, let's begin by finding out, are these planes parallel? Well, the normal vectors, well, let's say this is plane 1 and this is plane 2. Then we can call them n1 for the normal vector of plane 1. Right? And remember, that's given by just looking at the coefficients of x, y, and z in the equation of the plane. Okay? Well, so that gives us the normal vector for the first plane is 2 minus 3 and 4. And to get the normal vector for the second plane, we do the same thing. n2, let's put a little and in here. n2, read the coefficients, 1, 6, 4. So first things first, let's check if these are parallel. Well, n1 has a 2 in the first component, n2 has a 1 in the first component. So if these two vectors are going to be parallel, then I would have to multiply n2 by 2 and get n1, because that's how we would make the first components match. So let's just check real quick. Is 2 times n2, is that equal to n1? Well, let's write down what 2n2 is. All right, well, the first component we know is 2. The second component, the j component, we're going to multiply 6 by 2, and that's going to give us 12. So we could finish, and let's finish just for the sake of doing this. 4 times 2 is 8. All right. So once we knew that this was 12, it was already done, because this would have to be a minus 3 for this to equal this, for 2n2 to be equal to n1. But of course 12 is not minus 3, so they're not parallel. But this concretely says it here. So the conclusion is the planes are not parallel. Let's put a little exclamation point there. All right, well, if they're not parallel, that means they intersect. So let's get on with finding the angle that they intersect in. Remember, to do that, all we need to do is all we need to do is use the formula we had from the dot product. All right? So the cosine of the angle they intersect in, remember what we just did, this is equal to n1 dot product n2 over the magnitude of each of these. Magnitude n1, magnitude n2. Right? That's going to give us the cosine of the angle. And then once we have that, we can do arc cosine to both sides and actually find theta. All right, so how do we do this? Well, let's just compute this dot product. All right, so we're taking the dot product of n1 here with n2 here. So let's write a fraction out here. We're going to get 2 times 1 plus negative 3 times 6. Well, negative 3 times 6 is negative 18. So this is 2 minus 18 on top so far. And then the last thing is plus 4 times 4. So plus 16. Right? Now we need the magnitudes on the bottom. So here we have square root of 2 squared, which is 4, plus negative 3 squared, which is 9, plus 4 squared, which is 16. And we're going to multiply that by the magnitude of n2. Let's make that a little longer. Right? 1 squared is 1, plus 6 squared is 36, plus 4 squared is 16. Well, this particular example isn't going to be very hard to compute, because what is 2 minus 18 plus 16? Well, 2 plus 16 is 18. Minus 18, we're going to have 0 on top. So cosine of theta is just 0. So, well, when is cosine of theta equal to 0? That happens at pi over 2 and 3 pi over 2. But, if you look at what an intersection angle of pi over 2 and 3 pi over 2 are, well, you can't really see a 3 pi over 2 happening. Right? If you think of two lines, right? The biggest the angle could be is if the lines are the same, in which case you just have pi. So we don't ever actually have to worry about that. Right? So the angle of intersection is always going to be between 0 and pi. All right, so that means that theta is pi over 2. So what does that mean about the planes? Not only are they not parallel, not only do they intersect, but in this case the planes are actually perpendicular, which is kind of neat. Now that we've found the angle of intersection between the two planes, we can get on to what is sort of the second or third part of the question, depending on how you want to count, and finding an equation for the line of intersection of these two planes. Okay, so how do we do that? You'll notice I've conveniently gotten rid of all the information we don't need for this. So think about what are the two things we need for a line. We need two pieces of information. Do you remember? This would be a point on the line and the direction of the line. So let's first find a point on the line. How do we do that? Well, if the point is on the line, then it also must be on both of these planes. So we can use that to our advantage. To find a point on both of the planes, well, we have two equations. Each of them have 3 variables. So we can just choose, let's say, x to be whatever we want. And let's pick x to be 0, because 0 is a nice number. So if we choose x equals 0, then that tells us that whatever y and z is on this first plane, it has to satisfy minus 3y plus 4z equals 5. And if we plug in x equals 0 to the second plane, we get that 6y plus 4z has to be 3. Right? So now we just have to find a solution of this. There's a 4z in both of those equations, so let's subtract them from each other. And also let's put a 2 here. Let's subtract them from each other, and then we can get an equation with just y's in it. So since this one has the positive, since 2 has the positive, 1 has the negative, we'll take 2 and subtract 1. Okay? So equation 2 minus equation 1, that's going to give us 6y minus negative 3y. That's 9y. Right? And then 4z minus 4z, that's 0. And then 3 minus 5 is negative 2. So y has to be negative 2/9. Well, if we know y is negative 2/9, then we can plug that back into either of these equations and figure out what z has to be. So let's plug it into, let's say equation 2, since there's not a minus sign in it. Right? So we have 6 times negative 2/9 plus 4z has to be 3. All right, well, 6 times negative 2/9 is negative 4/3 plus 4z equals 3. Move this to the other side. 3 plus 4/3 is 13/3. And that's what 4z is equal to. Okay? Well, now we can solve for z. So z is 13 over 12. So a point on the line, is given by 0, negative 2/9, 13/12. So we're halfway there now. We have a point on the line of intersection. And actually, to be honest, this usually ends up being the step that takes more time of the two. Right? The second step being, of course, now that we need to find the direction of the line, or a vector in the direction of the line. So how can we do that? Well, remember, this line is contained in both planes. Right? It's contained in this plane, and it's contained in this plane. So what that means is the direction of the line is in the plane. That means that the direction of the line is perpendicular to the normal vector of the plane. Right? In other words, the direction of the line is perpendicular to this vector and perpendicular to this vector. So how can we get the direction of the line? Well, hopefully you're thinking to yourself, I remember. If I want something that's perpendicular to two vectors, all I have to do is take their cross product and it'll give me a perpendicular direction. And that's exactly right. That's what we need to do. So the direction of the line this is just given by, let's call it v for the direction. This is just given by n1, not plus, sorry, n1 cross n2. So let's compute this cross product. Right? So remember, top row, I, j, k. Second row should be the first vector. In this case, I've written it down to be n1. It really doesn't matter which order we do it in, but once we pick an order, we have to stick with it. So 2 minus 3, 4. Right? And then the third row should be the second vector. 1, 6, 4. Okay? All right. Remember, the order matters because if we flip these, we get a minus sign. That's the only difference. Okay. So, well, let's compute this cross product now. Okay, so remember the first one, we're going to suppress the first column and first row and do this little 2 by 2 here. Negative 3 times 4 is minus 12, minus 6 times 4, that's negative 12 minus 24. So that's going to get us a nice big negative 36 for the first component. All right, now for the second component, we suppress the first row and the second column. We're going to do our little 2 by 2 determinant. 2 times 4 is 8, minus 4 times 1 is 4. So 8 minus 4 is 4. But remember, in the j component, we get an extra minus sign. So this doesn't end up being 4, but minus 4. Right? And, well, let's do the last one now. Suppress the top column, the top row, the third column, and we get 2 times 6, so 12, minus 1 times negative 3, so 12 plus 3, and that's 15. Right? So that's the direction vector of the line. So we have a direction vector of the line. We have a point on the line of intersection. So we have all we need to make the equation of a line. So we've been doing a lot of, or we've done already the vector equation of a line, and we've done parametric equations of a line. So let's write this one as our insymmetric equations. Do you remember what those are? So let's write it in a nice blue here. So how do we write this down? Well, we start with x minus the x-coordinate, which is 0, or the x-coordinate of some point on the line. In this case, we have 0. Right? And then we have to divide this by negative 36. Okay? We could also leave off this minus 0, and since it looks nicer, let's go ahead and do that. Let's just erase this here. And so we just end up with x over 36. Okay? Or x over negative 36, sorry. All right, that equals y minus the y-coordinate of some point on the line. In this case, we're going to have y minus negative 2/9. So that's y plus 2/9. And remember, we're dividing by the j component of the direction vector, so minus 4. Right? And then we're going to do the same thing again for the z. Well, z minus 13 over 12, that's going to equal, we're going to divide that by 15. And this here gives us symmetric equations for this line of intersection. And that's it for this.